In exercise 5 of Module 3, the last exercise, we'll be creating the building model site. This is a little bit of something we've previously covered in terms of taking topography to the CNC router, but a slightly different edge to it, seeing as how this is working directly with the building. So we'll be exporting topography for CNC cutting, developing an understanding of how to use building pads, and again using 3ds Max to modify and export an STL file for CNC cutting. In the final video of Module 3, we're exporting this smaller portion of the topography to put the building model on. And what we want to be able to do with this is simply isolate using the section box tool. And then we need to verify the change in the topography for the physical model. Again, I'm working with a 2-inch thick material that I'm going to be running through the CNC router. And I need to set up a system that's going to validate that my drop across this site at scale for the physical model is going to be less than 2 inches. Then it's the same process that we used earlier, simply exporting this piece out, sending it through 3ds Max, and sending it to the CNC router. So let's go ahead and walk through that process. I'm going to go ahead and use my 3D view to establish an elevation view at a 16th inch scale. And we'll look at that in my CNC router page. And what I want to do is find my highest point, edge to edge, and on the sheet we're going to measure this distance because again at the sheet we're looking at this at a 16th inch scale. So I'm going to zoom in on this edge, use my measure tool, and go top to bottom. And I can note that I'm just a shade under 2 inches. So this should work really well. In particular, when I'm using the CNC router with a type of foam, either modeling foam or rigid building insulation foam, I always want to leave about a 1/4 inch, ideally about a 1/2 inch of material. It's going to make a more rigid model. It's going to give me reliable cutting, and it's going to make something that I don't have any warping on during the cutting process. So this is set up, it's ready to go. I know the size in the XY direction or the horizontal size is fine. I've continued to make some adjustments using the subregion tool. In particular, I've added parking and I've added parking striping as well. So you can identify not just sort of a great big open parking lot, but we can give it a little bit of scale and context in terms of how this is going to come together and work. So what we need to do next is essentially isolate this piece of topography so that we can send it to 3ds Max for scaling and some minor adjustments. So to do that, I'm going to make sure I'm selecting all of the topography, both the pieces that are driven by the building pad that was placed to help conform the building and topography together, and the topography itself. I'm going to isolate the element so you can see what's left. And it's a really good time to point out something that I've used as a technique. So I've developed both a building pad in this case, as well as a floor system. So you can actually see the two pieces layered one on top of another in the physical model. And this is something as the project moves forward to a complete BIM model, I might want to change. But this is the most advantageous way to build a physical model from Revit. In other words, I'm going to have the topography model, which is going to use the building pad, and I'm going to have the 3D printed model, which is going to use the floor system. And both of those are going to kind of work together for me. So let's reselect, re-isolate, and now let's run the export routine. So to move a file from Revit into 3ds Max, the most reliable way to do that is going to be using the FBX or film box format. So we'll go to the context menu, export, and FBX. I'm going to give that the file name, just delete the front end off of this and use the view name and save and leave on temporary isolate. And now we can switch to 3D Studio Max, where we'll import that FBX file. and accept the defaults. And then we'll go ahead and delete the sun and the camera just to keep things clear in the overall view. So same process that we've used earlier with a few modifications. We're going to select everything and activate the scale tool. And using the Excel spreadsheet again at a 16th inch, we know to reduce the overall file when it's at 1:1 is going to be 0.52% as my base number for the scale factor. So inside of 3D Studio Max, we have absolute transform mode on 0.52 to shrink this down from 1:1 all the way down to a 16th inch scale. So we're going to zoom all. And now we're going to manipulate the subregion. So we'll select the Move tool. Because we want to move this parking lot. In this case, previously when we were working with the road, we actually moved it up because that's what the rural roads were doing. But in this case, we're actually going to move it down so we can emulate a curb and gutter system for a parking lot. We'll move it down by a factor of about 1/32 of an inch. And again, at this point, we're actually working at a 1:1 scale. So that's going to be a 1/32 of an inch downward offset in my final physical model. And if you can note, I've left the parking stripes as part of the other subregion. And that's so that as the CNC router is making the cuts, I'll actually have those parking stripes in my final model. I'll get that context and I'll have some understanding of exactly how that's going to work and look in that final physical model. So this is ready to export now as an STL file. And we'll give that a name, and that'll be ready to open up in the CNC router software. Again, make sure selected only is turned off just for safety's sake, and say OK, and that file is ready to go. The final model is out of the 3D printer and on the site, and everything's looking pretty good. There's still a few things always to touch up here and there, and always another piece that I'd like to print out again. But this is a pretty good starting point to begin adding in some additional details. So from this lesson, we learned how to export the building-specific portion of the site at the correct scale, use building paths to modify and set topography up to work with the building model, and create modifications in 3ds Max to create a better physical model.